In this video, I'm going to show you how to use L'Hopital's rule to calculate some undetermined limits. So in the previous video, we learned that L'Hopital's rule says that for two functions f of x and g of x, and g dash and f dash both exist, then you can calculate the limit when x goes to a of f of x over g of x as the limit when x goes to a of f dash of x over g dash of x. And I gave you as an example one limit where you could use L'Hopital's rule would be the limit when x goes to 1 of ln of x over x minus 1. In order to use L'Hopital's rule, you need to first make sure that you do have an uncertainty of the case 0 over 0 or infinity over infinity. Remember, you're not allowed to use L'Hopital's rule if you don't have one of those indeterminations. In this case, we already did the check, but we can do it again. When you substitute 1 into ln x, you get 0, and when you substitute 1 into x minus 1, you also get 0, so we are in the case of 0 over 0. So to calculate this limit using L'Hopital's rule, all we have to do is differentiate the numerator and the denominator independently. So starting with the numerator, derivative of ln x, we know it's 1 over x. Over the derivative of x minus 1 is 1. So this means that the limit when x goes to 1 can be simplified to the limit of 1 over x. And 1 over x has no issue at 1, so we can evaluate the limit by substituting 1 into 1 over x. And we get that the value of the limit is 1. Another example is the limit when x goes to 0 of sine of x over x. When we first introduced limits, we talked about this limit and we tried to calculate what the limit was through using a table of values. So we know that the value of this limit is going to be 1. But using L'Hopital's rule, we can prove this by taking the derivative of the numerator and the denominator. So first of all, we need to check that we do have the indetermination. So if we substitute 0 in sine of x, we are going to get sine of 0, and that is 0. And of course, if we substitute 0 in x, we also get 0. So it is an indetermination of the form 0 over 0. So we can use L'Hopital to calculate the limit when x goes to 0 of the derivative of sine of x, which is cosine of x, over the derivative of x, which is 1. So when we evaluate cosine of 0, we get equal to 1. We can use L'Hopital's rule also to calculate limits that are from one side. We can also use L'Hopital's rule to calculate lateral limits, but also we can use it to calculate the limit of some special products. In this case, we have the function x ln x, and if we check for which kind of indetermination we have, we're going to see that if I substitute 0, I'm going to get 0 from x, and I'm going to get minus infinity from ln x. So it's not quite 0 over 0 or infinity over infinity. However, I can rearrange this expression so that I have that kind of proportion, ratio. So the first thing I want to do is I want to move the x from the numerator into the denominator. But when I do that, it doesn't go as x, it goes as 1 over x. And now if I check for an indetermination, I'm going to see that ln x goes to minus infinity at 0, but 1 over x goes to infinity at 0. So now I have an infinity over infinity. That is an indetermination. So I can use L'Hopital's rule to differentiate this function. So this should be limit when x goes to 0 from the right of derivative of ln x is 1 over x, and derivative of 1 over x is minus 1 over x squared. Now this is equal to the limit when x goes to 0 from the right of minus x. And if I evaluate that at 0, I'm going to have 0. Let's do another example with this same principle. For example, consider the limit when x goes to minus infinity of the function x times e power x. When I do this check to see what kind of indetermination I have, I'm going to substitute, let's say, minus infinity. So this would be minus infinity. And if I do it in e power x would be e to the power of a negative, very, very big number. And that is going to go towards 0. So actually, I don't have an indetermination of the kind that I can use L'Hopital on. So I can move either x or e power x to the denominator to change the indetermination. So I'm going to move the exponential in this time. So e to the power minus x in the denominator and x in the numerator. And this is equal to limit when x goes to minus infinity of, now I'm going to take the derivatives. So the derivative of x is 1. The derivative of e to the power of minus x is e to the power of minus x times minus 1. So when I evaluate to minus infinity, e to the power of minus infinity is a quantity that goes towards positive infinity, very, very large. And dividing 1 by a very, very large number is going to give me 0. So this limit is going to be 0.